In 1990, NASA launched one of the most ambitious scientific instruments ever built, with a very specific goal: to escape the optical limits of our own planet. If you've ever looked up and noticed the stars twinkling, you're seeing the first major barrier to ground-based astronomy. Air currents in Earth's atmosphere constantly shift, distorting and blurring the light that passes through them. The atmosphere also acts as a physical wall, completely absorbing incoming ultraviolet and parts of the infrared spectrum before they ever reach the ground. To bypass those blindfolds, the Hubble Space Telescope was placed into low Earth orbit. Getting absolute visual clarity meant leaving the atmosphere behind entirely. But immediately after reaching orbit, the first images beamed back to Earth were disastrously blurry. The telescope relies on a massive 2.4-meter primary mirror. At the time, it was intended to be the most precisely polished optical surface in history. From a manufacturing defect called spherical aberration, the outer edges of the mirror were polished too flat by 2.2 micrometers, a fraction of the width of a human hair. Look at this diagram of a curved mirror. When incoming parallel light rays hit the surface, that microscopic flattening error means they don't bounce back to meet at a single focal point. They scatter into an unfocused cluster. A multi-billion-dollar observatory built to map the cosmos was crippled by an error too small for the human eye to see. Fortunately, Hubble was designed differently from earlier satellites. It was built as a modular system that astronauts could manually service in the vacuum of space. In 1993, a crew launched into orbit for a high-stakes intervention known as Servicing Mission 1. To understand the fix, you need to understand the telescope's specific optical layout, a system known as a Ritchey-Chrétien-Cassegrain design. Here is a schematic of that layout. Light enters the open tube, bounces off the large primary mirror at the back, reflects forward to a smaller secondary mirror, and then shoots right back through a central hole to reach the scientific instruments. The astronauts installed a corrective optics module called COSTAR. It intercepts that exact light path just before the sensors. By applying a series of corrective lenses that act like eyeglasses, it perfectly realigns those scattered rays. Treating the spacecraft as a repairable system solved the optics problem and established a model for maintaining permanent infrastructure in orbit. With its vision finally focused, Hubble began capturing the universe across 3 pristine spectrums: ultraviolet, visible, and near-infrared light. By observing distant pulsating stars, known as Cepheid variables, astronomers gathered the data required to pin down the age of the universe to precisely 13.8 billion years. This chart maps the expansion of the universe over time. Notice how the curve unexpectedly bends sharply upward in recent cosmic history. This observation proved the expansion isn't slowing down under gravity, it's accelerating. It provided the direct evidence for dark energy. Then, astronomers pointed the telescope at a seemingly dark, empty patch of sky. The resulting image, the Hubble Deep Field, revealed thousands of ancient, distant galaxies in a single view. Hubble also pioneered the analysis of planets orbiting other stars, detecting chemical signatures like water vapor, carbon dioxide, and sodium on worlds light years away from our solar system. Correcting the mirror provided the exact mathematical measurements necessary to understand the origin, composition, and trajectory of reality. Today, a new generation of observatories has launched, most notably the James Webb Space Telescope. Webb operates with a different mandate. It looks deep into the infrared spectrum, allowing it to pierce through thick cosmic dust and observe the earliest stars forming. Hubble is still actively operating. It remains our most powerful eye for visible and ultraviolet light, working in tandem with Webb rather than being replaced by it. Born from a microscopic manufacturing error and saved by an orbital repair mission, Hubble stands as an enduring testament to human ingenuity, a machine that mapped our exact place in the cosmos and continues to look back at us through the universe that helped us discover.